Here we will build a simple refinery flowchart. On the left you see the crude oil feed to the refinery. On the right hand side, the major refinery products going from the lightest to the heaviest, starting with gasoline, jet fuel and kerosene, heating and diesel fuels, industrial fuel oil, waxes, lubricating oils, greases, asphalt, and petroleum coke would be the heaviest product, which will be a solid obtained from a refinery. The crude oil is fed to the fractionating tower that we call the distillation column, which separates the crude oil into various boiling fractions. And these fractions are fed to the processes, the downstream, which are vapor recovery unit, ultra-forming, alkylation, catalytic cracking, extraction, coking, dewaxing, grease manufacturing, treating and blending, among others, and there's additional processing there as well. So we essentially will connect the crude oil through these processes to the final products. Please note that some of the refinery units are connected. If you look at vapor recovery unit, connected to catalytic cracking, and that is also connected to coking, and at the top is ultra forming. Now these processes all produce gasoline and light hydrocarbons like LPG from different boiling fractions of crude oil coming from the distillation column. That's why they are linked on this diagram. Let's follow what happens to different distillation fractions coming from the distillation column. First, the vapor product from the top is sent to the vapor recovery unit and separated into gasoline and LPG, that's liquefied petroleum gas. You can see the ultra forming, we call now the process catalytic reforming, is involved to make a high octane gasoline. And see that additional processing is also needed to remove sulfur from these products, LPG as well as gasoline. We should note that catalytic cracking can also produce jet fuel. As you can see, the arrow from cat cracking touching the jet fuel line. And catalytic cracking also produces feedstocks for the alkylation unit to produce additional high octane gasoline. As we go down the distillation column, we are now into the vacuum distillation territory, and the product from vacuum distillation would go through extraction, dewaxing, and various treating and blending to produce lubricating oils, as well as waxes and greases. We are now at the bottom of the vacuum distillation column, the vacuum distillation residue. Can do various things with this fraction. First is coking. It's a very severe thermal cracking process which leads to petroleum coke as a byproduct. Refineries use coking to produce more jet fuel, gasoline, and LPG. Petroleum coke is just a byproduct. The vacuum distillation residue could be treated in a deasphalting process to produce asphalt, again as a byproduct. The principal product from deasphalting, called deasphalted oil, could be used making lighter hydrocarbons, fuels and chemicals from this fraction. And this pretty much completes our building of a very simple refinery flowchart.